In this video, I'm going to be talking about multi-threading using the objects of future and promise classes. Promise is an object. A promise object is to be passed into the task as argument. So a task has to be designed so that it can receive a promise type object. This promise object is going to have a shared memory associated with it, where the object passed into the task can write data into. And future class is related to promise. A future type object associated with the argument promise object can be used to access the data written into the shared state by the promise object. Let me get into coding and explain it one more time. These promise and future objects they're available through library called future. And if I have a task, let's say, to perform certain things, then I will, to use this promise and future, I will need to pass a promise object. And this is templated, so you need to specify the type of data you want to write into. Let's say it's double promise object, and you have the function may have its own logic, and at some point of time you need to use that promise object to write the data using by calling this function set value. You can write a double type data into it, 3.6, something like this. Right, this is the structure. This is the structure of the task you design when you want to use promise object. Now, from the point from where you want to call this use promise future pair, here first you create a promise object that is that you will essentially pass into the task P1, and this promise has a function called get future, which returns the future object that is associated with P1. So this is the type of the object it returns, future P1 dot get future. So now we have two objects associated with two objects, promise and future object associated with the same promise object. If I want to call the task, I need to call that in a thread. I need to create thread in this case, and for that I need to have a thread library on the top. Thread object. Inside thread object, I need to specify the task, name of the task, and this promise object, because this function has no other parameters, so only pass promise object. But since this is a reference and we need to specify, we need to call the reference function and pass the promise object into it. So this is the way you create a thread. Once this thread is created, then it gets executed in t1.join. You do the synchronization, and after that you can use a future object data equals to, you can use a future object and call the function get through the future object to get access to the data that was written by the promise object within the thread execution of the thread. And you can display this data. So let me show you again. So you can display the data that was received by invoking the get function using the future object. Right now we have one thread executed, synchronized properly, promise object passed to the thread and to the inside the task, and it would set some data into that shared state by calling this function, and we have future object to get access to that data. Okay, let me see the output of this code. So let me compile this code. Compilation, execution. Now 3.6 is the data that was displayed and accessed by using future object. Right, this is how this pair of promise and future works. You have promise object and you have a corresponding future object. You pass promise object into the tags in the thread, and that promise object will set the data into the shared state, and you have already future object in the place from where you created the thread, and you use that future object to get access to the data. Now let me make changes to this function to make it a little bit different, or compute the average of very large size array. If I want to compute average, then let me change this name to average, and I want to pass an array to it and size, right, and also the promise object. What I want to do is I actually want to compute the average and use this promise object to write data into the shared state, so that the computed average value can be accessed by calling the get function in the main function from the point of call, from the place from where this thread is being invoked. The logic for computing average would be first I define a variable called average, and in the loop I plus plus summation, compute the summation, and compute average. Then I can use this call this function to set this average value into the shared state, right? So this is the way we can compute data and share data from the thread to the main thread. Now when I create a thread, I need to the task name is different now, average. I need to also create a data. So let me have a constant. The size of the array would be 5000000. This is 6, and array, and let me populate this with the random numbers by using STL algorithm. First address of the first element, address of last element, element after the last, and I have the lambda expression here, int x, x equals to append percentage 100. So this is this will actually essentially write the random integer in the range from 0 to 100 into the elements of this array. And if you want to see the sample of those elements, copy first 10 elements. Wisdom iterator for it's going to be integer type. Right, first 10 samples and last 10 samples. So I want to separate this to data in different lines. So this is this will one column missing. So this will display the first 10 and last 10 data items that were written by this for each function into this array, my array. Let me first compile this and show you the output. Then I will move on from there. So compile and linking. There's a problem. Yeah, the problem here is there are two problems basically. Let me go back to the code, try to fix it. So one problem is this type. The type of this size is size t. So it's not problem. There's a warning. So let me fix that warning. And to use iterator, you need to include the library iterator, and also for each you will need to include the library algorithm. Right, with this I hope the problem will be solved. Still there's one additional problem. Reference wrapper promise double. Okay, let me go back to the code and try to see what is the problem. So I think this function is this is not properly called. So I think maybe I need to comment this thing out for a moment. Okay, again. Now it is running, but it's not displaying anything. Probably the problem is the size of the array, because if the system doesn't have space to hold this much size. So let me see one. Oh, this is too much. 1 2 3. Yeah, this is too much. Let me remove 1 0. So I think this should be okay now. So let me compile and show it again. You can see the output, the data, first 10 items, data elements, and last 10 elements. Elements are in the range from 0 to 100. Now going back to the code. Now I want to make use of promise and future pair to compute the average of this array by running this average function as a task. Okay, so for that let me make changes to the code that we previously had. Average is the task, but the second argument we need to pass is the array, and the third is size, and fourth is going to be promise. Right, so let me pass array and size, and I would like to change this promised future name to P and F only, not P1. Thread only T. So with this I want to actually, let me explain it one more time. I have promise object and corresponding future object. A promise object is passed into the thread, into the tags, and that past promise object actually did write the computed average value into the shared state, and the future object actually is used to get access to that data that was written, and data, this is identified that actually copies data into it, and it is used to display the data on the output screen, and this is the line for synchronization. Let me compile it and show you the output. Successful execution. Now this was the average value displayed, but I should have put a new line character before at this point, because after I display this data I need to have a new line character. Then it will display, but let me put some text here. Average so this is the average computed using only one thread, but if you want to compute the average by running this tags in 4 different threads, so that each thread will process 1/4 of the array elements, non-overlapping elements. In that case we can do as follows. First, let me create a size of the smaller array, size sub, that means size of sub array equals to 4, and we need to create 4 future, because we need to run in 4 threads. That means we'll have to 4 different promise future pair. We cannot use the same promise future pair for different thread executions. We need to have different promise future pairs. So let me copy this and make changes so that we have 4 different pairs: P1, F1, P1. These are one pair. I have another pair, P2, F2, P2. I have a third pair, P3, F3, P3, and I have fourth pair of promise and future objects. So we have these 4 pairs, and we can create 4 different threads, passing 4 promise object into it. T1, two, 3, 4, and we pass different promise object into them. 2, 3, 4. Now passing this array is going to be you need to make some changes. In the first thread I want to pass first 1/4 size, which is going to be size by, you can use size by 4, size divided by 4, or you can use the sub size we calculated here. So size sub, and in the second case we want to send the address of the element at that particular index, and the size is going to be again size sub. In the third case, 2 times size sub address, again size sub number of elements, and in this case 3 times size sub Now in this case, the size, we cannot use sub. If we use sub, it will not give a correct result, because it will actually leave the maybe few elements here, probably either 1, 2, depending on how the division happens. Some elements will be left, maybe probably in this case 2 elements will be left in this case. So the size we are going to use here is going to be size, total size minus 3 times size sub. So this is going to be the correct number of elements, so that all the leftover elements are going to be incorporated in this thread. Now afterwards, we need to synchronize T1 dot join, T2 join, T3 join, T4 join. So this is a synchronization process. With this, now we can get access to the data by using this future objects F1, F2, F3, F4, similar to what we have done here. So let me change the name to avg1 and f1.get, and avg2 equals to f2.get, avg3 equals to f3.get, 4 equals to f4.get. So these are different averages for different subsets of the array, sub-arrays. You need to combine to create the average for the entire array. So the way of doing that is multiply this average one by the number of elements in the first subset, and that will give you total summation of the elements, and summation of elements, and summation of elements for the third sub array, and summation of elements in the fourth array, and you divide entire total summation by the size of the entire array. So you can do like this: abg1, maybe put in the parenthesis, abg1 times size sub plus abg2 times sub plus abg3 times sub plus e4 times size minus 3 times sub divided by size. This is the expression which will actually give you the average of entire array. Right, so this should display the average computed by running 4 different arrays, and this line actually displayed the average computed by using only one thread, 4 thread versus 1 thread. So let me switch to the terminal and compile and run it again. Now you can see the average computed 49.4921. You can see 49.4920. This is precisely the same. Okay, average computed. But if we had computed the time required to execute, this would be faster. If we computed the time from this point to this point, or from this point to this point, this would be faster. Okay, I have not planned to show you that, but if you are interested, you can do that. See the time that is required from this point to this point, and see the time that is required from this point to this point. Obviously this in the second case it will be much faster. If you have you are running in a computer that contains multiple cores, maybe 5, 6, 8, depending on how many cores you have. So this is the end of this video. Thank you for watching.